Hi everyone. In this video I am going to tell you about the fabrication steps of bicmos. So this is bicmos. Bicmos is bi stands for bipolar junction transistor and CMOS is complementary metal oxide field effect transistor. So this bicmos contains both BJT as well as CMOS. So in the CMOS we have NMOS as well as PMOS. So we need to fabricate NMOS, PMOS and NPN. So collector base emitter of BJT. So ultimately we need to fabricate source gate drain terminal of NMOS and source gate drain terminal of PMOS and also base emitter collector of NPN transistor, that is the BJT, bipolar junction transistor. So for that the steps followed are, first of all we should take a P substrate. On the P substrate silicon dioxide layer is deposited. Then a window is opened here. This window is for the BJT. So this window can be opened using the photolithography process. So throughout deposition of oxide, growing the photoresist, using the appropriate mask and making the UV light to fall, all these steps are involved. So for the sake of simplicity, all the steps are not shown. So this window is opened and on that window, through that window, a N plus buried layer is deposited. So this N plus buried layer is deposited underneath the window. Next, the epitaxial layer is grown on the entire surface. So epitaxial layer, epitaxy means epi means upon, taxis layer. So layer is grown upon the other layer. So this is growing epitaxy is very sophisticated and costly process. But whenever we want specifically, we need to do the epitaxy. Here again two windows are opened. So we know one window is for BJT, the other window is for the MOSFET. And here in the same step of formation of N-well, both these two steps are merged. Here what is the purpose of forming the N-well? So this N-well serves dual purpose. N-well acts as N substrate for the PMOS and this N-well acts as N collector in the NPN transistor. So whenever possible we need to merge the steps of CMOS and the BJT. So here it is possible because the N-well itself acts as N substrate for the PMOS and it acts as collector for the BJT. So next we are opening 3 more windows and we need to do the polysilicon deposition and underneath that deposition of the thin oxide so that it acts as MOSFET, metal oxide semiconductor. In the place of metal we are using the polysilicon. So this step is common. This polysilicon deposition serves formation of gate for NMOS as well as PMOS and oxide layer deposition, thin oxide layer deposition is also done in the same step. Next is formation of P base. So in the NPN transistor, this is the base. So this step is not in common with any of the other steps because we know doping concentration of emitter base collector are not same. Base is lightly doped, collector is moderately doped, emitter is heavily doped. So these doping concentrations are known to us. So lightly doped this P step is not common for any of the steps of the MOSFET. So this is the extra step. Then N plus diffusion is done. Here we can see the green color. This N plus diffusion is done for forming the source and drain of the MOSFET. So it is the N MOSFET. We know for N MOSFET this P type of epitaxy is acting as a substrate, P substrate, and this N plus diffusion serves the source and drain of the NMOS. In the same step, we can see N plus emitter. This N plus emitter acts as the emitter of the NPN transistor. N way acts as the collector, P base acts as the base, and N plus itself acts as a emitter. And we can see a small pocket opening here. So what for this small pocket is opened? This is opened for forming the contact of the N-well collector. This N collector is not heavily doped. So we need to moderately doped N-well collector should need a contact. For that, N plus doping is to be done through this small pocket. Then P plus diffusion is done, and P plus diffusion is used for forming the source and drain of the PMOS, for which N will act as a substrate, and P plus diffusion helps the source and drain formation of the PMOS. And we can see this olive green color, this is acting as a small pocket is opened for the P base. It serves as the base contact. So whenever possible, we will be trying to merge in the same step for the BJT as well as the MOSFET. Then again growing throughout with the oxide layer. So, and etching wherever we don't want the oxide, and depositing the metal, that is metallization, for connecting to the outside world. Source, gate and drain of NMOS, source, gate and drain of PMOS, emitter base collector of the BJT. So this is the fabrication process of the bicmos. The extra steps involved is the formation of P base and this buried layer. This buried layer is used specifically for avoiding the latch-up problem which we used to have in the CMOS. So if we use this buried layer, we don't have the latch-up problem because it acts as a guard ring, and also to reduce the collector resistance of the BJT. So buried layer serves two purposes. Buried layer is used for preventing the latch-up problem in CMOS and reducing the collector resistance in the BJT. So this is the fabrication process of the bicmos. Thank you one and all.